Recording in progress.
Hi friends, greetings. Welcome to the session. Today we are connecting here to discuss about the data engineering and its modules. I'll try to give you an overview of what exactly we are going to learn as part of this program. And right, we will also try and see how the journey is gonna take shape. To start with, let me introduce myself. My name is Sharad, and I'm one of the directors with Innodatatics. Let me open my LinkedIn. This is my profile. Yeah, so I'm one of the directors with Innodatatics, and we take care of AI solution development. It's not just development, but of course, we also have to deploy it to the customers. And this is where my core work area is into. So I basically take care of the implementation using the MLOps standards. And in order to ensure that there is a smooth implementation, we also have to develop the automation into the machine learning development. And that's basically what data engineers do. So we'll try and understand the specific aspects that as a data engineer, right, the skill sets we should possess. So as soon as we talk about data engineers, we have to think about data pipelines. But what exactly are these data pipelines and why they are coming into the picture? So first of all, let us understand what exactly is data engineering. So when I talk about this data engineers or data engineering, personally, I call them as plumbers, data plumbers. There's a lot of similarity between a data engineer and a plumber. For example, what do a plumber do as part of a house construction? Like we're basically getting a house constructed, and obviously there is one of the key role, right? The plumber plays in. So what exactly does this plumber do? So when we talk about plumbing, these plumbers are responsible for designing, right? The design basically, because they have to plan it. And then they have to implement it, right? They have to build it, build the pipelines, connect them and all that. And it's just not that. They also are responsible for maintaining these pipelines for ensuring that there is smooth flow of water, isn't it? Now, I would try and correlate the job of a plumber for a data engineer. What data engineers do is very similar to what plumbers do. As a data engineer, we are responsible for ensuring that we design, we integrate and build, and we also maintain something called as data pipelines. So here, data is going to be compared with water. A house is nothing but an organization. Now, if you look at the like water consumption in a house, there are different outlets where we are consuming the water. It could be in toilets, it could be kitchen area, it could be wash area, it could be gardening, right, in the garden area. So there are various touch points where the water is consumed for different purposes. And if I talk about the source of the water, from where the water is coming, it could be an overhead tank, it could be direct pipeline from the government authorities, the municipal authorities. So the rainwater harvesting could be done, right? Underground water could be there. So sources can also be there. As a plumber, we need to ensure that the data is collected from multiple sources, accumulate that into a specific location for the consumption in the house, and from there we again connect so that we get the water into specific location, so that the consumption is happening with respect to its purpose. Okay, what is it used for? Why we are using that water on specific field? It has its own role and responsibility in that area, right? So this is what plumbers do with respect to water, and that is exactly what data engineers are responsible to do, as I mentioned. Data comes from various sources. We accumulate that data, ensure that the data is stored into a specific repository. From there, again, we push it to destination. In the organization, we will have different people using the data for different purposes. Reporting purpose, research purpose, isn't it? So we actually have to ensure the respective teams are getting the desired data in its desired form so that end users can use it readily into generating business value. So that's what data engineers are supposed to do. Now, when I talk about this data engineers role, right, I was directly comparing it with plumbers. But if you look into the specific, I should say, role or responsibility of a data engineer in a practical sense for an organization, a data engineer deals a lot with different, I should say, hardware and software systems. Basically, they deal with IT because ultimately they'll have to communicate with multiple tools, right? So they should be more technical in nature. And that's how these people are a little different from data scientists and data analysts that basically we are very popularly aware of. But how do we actually compare them, and what is their position, data engineer's position in this entire value chain? So if I talk about a data scientist or a data analyst, they can do their magic only when data is made available to them. As a data scientist or as a data analyst, they're not expected to gather the data. They're not expected to bring the data from these different sources. The primary objective of a data analyst or a data scientist would be to ensure they generate the value from that particular data that they get received from, right? Various sources, they can get the data from different sources, but ultimately they will get the data. Now, a data analyst generates reports using business intelligence tools, and those reports can help the management to understand what happened and they probably come up with some strategies. A data scientist is more towards implementing analytics, machine learning, predictive analytics, and all that. So data scientist or a machine learning engineer takes the same data, cleans it, of course, and then generates predictive models so that they can generate the correlations between various factors which are causing an effect on the desired output. And that basically again helps the management to come up with some strategies to control the outcome that they want. But as I told, unless until these people are given the data, they cannot do their magic. They need data. So we are talking about the flow of data into the system. And this is exactly what data engineers do. They ensure data is made available to data analysts or data science teams or whatever the respective teams that the organization is having. People who want to consume the data, right? They need to have the data received at their point. This is what we call as destination. If you remember, I just have explained that we will have sources of data, and then from that sources we accumulate, and then we give this data to different people. So here you can have data analysts, here you can have machine learning expert, here you can have reports, right, reports team. So there are many different teams who are consuming the data for different purposes. So this is basically what a data engineer do. They ensure these connections are established in effective manner so that the data is always made available for them. These connections basically explain the flow of the data, and we call this entire exercise as data pipelining. So in short, a data engineer is responsible for designing, that is planning, designing, building, and then ensuring that this data pipelines are consistently working as expected as part of the maintenance. This is, in short, the definition of a data engineer role. But what exactly is this data pipeline? Where does this come into picture? So let us try and understand. When we talk about a data pipeline, the objective is to move the data from one point to one point, right? That is from source to destination. But again, this could be very, very complex. Because in certain organizations, you may have only one touch point where customers interact and data is getting generated at this one point. So this becomes the source, and you're moving that to a destination where the various other teams can actually get the data and then use it for their respective purposes. But what if the organization has different touch points? Nowadays, all the solutions that the companies are building have different touch points. When I say touch points, the interaction points. Customers can interact from mobiles, customers can interact from indirect sources via different channels. Customers can interact directly over a website. So there are various platforms where customers are interacting with a product or a service. And this would be one of the important touch points, one of the important areas where data is getting generated. So I'm calling all of these as sources. Now, these sources could be external. That means external clients could be there, or we may have internal clients. Internal team could also be there. Employees could be there, right? So there are various data sources from where data is getting generated. The point is, at each of this touch point, we call it as touch point or interaction point, the tool, the interface, or you can say the technology, all of these are varying. Customers are also interacting at these different touch points in their respective way. So the expectation is different at each point. So what happens is, because of the technology change, the expectations change, right? The format of the data will also be completely different. One point to another point, the format of the data which is getting generated could be completely different. Say, for example, a customer is interacting with the web application, like a website, a web form probably. When customer interacts with us, the data gets generated and the data is getting stored into a system. So this would be in one format. A customer could make a call directly to the customer care executive or some interaction point, a service provider, right? We'll have different touch points on the road. So maybe there is a service desk and customers are directly interacting there. So in this case, the data will be in a different format, isn't it? Audio and video, for example. So the source that we are looking at can have different format of data. And then we are trying to integrate these different systems together so that we can get all the data captured from different sources, so that we combine everything, collate everything, and ensure that there is one master data record, one location where entire data is available. This is your data repository, where you dump everything. Now, once this is done, Depending on your team's requirement, you may have different teams working on this particular data for different purposes. So you can see the complexity is growing, isn't it? And the format is different. So you also have to ensure that there is a consistency in the data with respect to data format. So we are also doing transformation of the data. So it becomes very, very complex job over a period of time for any organization. But when we are also trying to do that, right, we need to understand how the data is actually flowing. And when we talk about this entire pipelines, these pipeline architectures can be broadly categorized into three different forms. One is called as batch data pipeline, and this is simple. And this has been the industry standard for ages. We call it as batch data, where we try to take the entire data from one location to this location. Maybe at night, right? So when the operations are lean, there are no operations basically, right? In the night, the data will be moved into this repository so that, right, I can shut down all this and then copy it into a different system and then push it. So at this time, the operations will not happen. We're throwing the entire data, right? Whatever we have collected for that day, for example, a month, all the data will be moved at one go. This is called as bulk ingestion. Bulk ingestion. Bulk means entire data will be ingested. Ingested means pushed into this. Right? Here we are recording. But nowadays, even if you talk about bank transactions, for example, we need to have the live data. Right? OTT platforms is one of the classical examples you can think of. Bank transactions is another classical example that you can think of. So when live, right, activity is happening, like transactions are happening, at that point of time, we need to push the data into repository so that we are always up to date with respect to the information. Here, the continuous flow of data happens. It's not shut down. As the data is getting generated, we push it there. As the data is in this, it is actively data is flowing. This one is called as streaming data pipeline or real-time streaming pipelines or live streaming pipelines. These are different terminologies that we use. Real-time. That means as and how the data is getting generated, we try to. This is offline. We call it as offline. Here we also call it as online. Now, how about combining these two? There will be systems where you already have moved the data. Okay, this is assume source, this is destination. We have all the data moved. But what is happening is because of some operations, the data which is already pushed is makes changes here. Some updates can happen. So in such case, I don't have to move everything, isn't it? All the data is not required. But at the same time, I want to ensure that this data which is changed is not a new data which is already there. Okay, there's a record, and in this record, some changes happen. So only that change should be reflecting here. This is like refreshing the data. We call this as CDC. Change data capture. So anything that is changing, that change should trigger the flow, and this repository should get updated. It is more like real time for that particular record, that particular value. So it's combination of these two. We already have moved the entire data, but when change happens, only the change is reflected. So these are broadly three different types of pipelines that industry uses with respect to the data flow. We are responsible for constructing these pipelines depending on the nature of the business that we are working for. This is a typical image which I really liked from online. So I just put it in the presentation here. You can see that right, this is basically picked up from StreamSets, which is also basically an organization which provides products to build the data pipelines. So if you look at this, this is your sources. We have different sources. This is offline. This is big data system. This is the naturally the database softwares which majority of the organizations use. You can construct APIs. This is for real-time streaming. We have Kafka. It's a messaging system basically. And depending on the requirements, we probably can construct any one of the pipelines or all the three, depending on the nature of the business that we're doing, as I said. And here we are ingesting. But in different formats, I mean, these different sources that we look at, right? The different technologies being used here. Each source that we look at has data stored in a different format. They collect the data in a different format altogether. So here, when the data is getting accumulated, we ensure that we also do some transformation to the data, bring it into a consistency. And then once the data is consistently transformed to a specific format, that data, clean data, I should say, clean and transformed data, will be moved into the destination. These are your destinations. This is your source. This is your destination. Depending on the nature of the consumers, you can again broadly classify your destination into either data warehousing systems or data lake systems. Right? So broadly, two type of destinations will be there. And you can see data scientists and ML engineers consume the data from data lakes preferably, and the reporting and all that can happen from the data warehouses. So as part of this program, we are going to try and understand these different sources, the technologies, and at the same time, we are also talking about different destinations, data lakes and data warehouses, how these systems are basically used and consumed. We'll also talk about the art of doing transformation on the data, various manipulations that we conduct, right? So what are those? What is the definition of each of those transformation techniques that we implement? And then how do you ensure this connections are established? We basically talk about ETL tools. ETL tool or ETL pipelines is what we are going to construct, but we don't only do ETL, we can also talk about ELT. E stands for extraction, extract or ingest. T stands for transformation, transform the data. And then L stands for load. So if I have to talk about ETL, this is the order: extract, transform, and load. And if I talk about ELT, it would be extract, load, and then transform. Again, depending on the need and the nature of the business, we apply this, right, one of the pipelines for ensuring that the data connectivity data flow is happening into the entire connected pipelines. So this is a broad overview of the content that we are basically going to study as part of this program. So I'm trying to bring in the comparison between data engineers and data science, which is one of the popular terminology in the industry. A data engineer would be a link between the data strategy and data scientists. What does this basically mean is, if data scientists have to do what they are supposed to do, they apply statistical and machine learning and analytical approaches to bring a solution to business problems, right? And these basically is done by trying to identify some kind of a pattern in the data. So they give you this actionable insights by applying these statistical and machine learning and analytical techniques. But in order to do that, they need data, right? So data engineers provide the data. So from data, different data strategies, nothing but different data touch points. From these sources, data is made available to data scientists. So these data engineers are the key here. They are the link. As I mentioned about the definition, data engineers are responsible for designing, building, integrating, and of course, maintaining the pipelines.
Hi, sir. I'm audible, right?
Yes, I can hear you.
I have one query. Can I ask that? Else, end
Yeah.
of the section, can I ask?
Go ahead, go ahead. Anyways, now we discuss.
Yeah. Actually, here topic comes my query related. That's why I need to ask. Okay. Actually, I have 2 years experience on data analyst. Okay. So, is it better to move as a data engineer as data science?
Okay, see,
Yeah.
I mean, if you talk about which body part is important, we cannot distinguish, right? So, an entire organization works, IT department of an organization works with different things, like our body works with different parts. You cannot say that this is more better than this or this is important than this in the organization. Each part has its own role and responsibility. Likewise, data analyst role is important, data engineer's role is also important. It depends on what are your skill sets, what is that you are inclined towards. Depending on that, you'll have to choose which area is better for you. A data
Okay.
engineer, predominantly, as I explained till now, data engineer predominantly is a more technical job role because you'll be dealing with all the different softwares. You'll have to manage those softwares, you'll have to integrate them, you'll have to try and ensure that these systems do not break down. It's more of a technology driven role. Whereas a data analyst is basically a person who is going to use one or two tools and work on the data to generate reports. So you need to have more logical thinking, you need to have presentation skills, reasoning skills. So an analyst role is different from a data engineer with respect to these, right, broad mindset that we're talking about. Technical role, more logical role, right? So purely depending on your mindset, it doesn't purely depends on what is your education or work experience till now that you have, right? Education background or work experience, but it also depends on where your mind is inclined towards, right? What is your mind and heart says, right? So that is important for you to motivate yourself to drive yourself into this area. And I'm just explaining in a very broad sense so that, right, other people who probably have the same kind of a question can make sense out of this answer.
Sure, sir. Thank you. Got it.
Yeah, yeah, well. All right, so comparison, as I told, these people are more technical in nature, and these people come in the forefront. And because of these data engineers, data is being made available for the remaining teams like data scientist teams. These data scientists, as I explained, are expected to explore, dig into the data, try and define various, I should say, correlations between the data features, which are extracted or which are gathered or collected as part of the business operations, which could be directly impacting the business operations or indirectly impacting the business operations. But we are trying to find out various questions and also trying to find out answers. This is the role of a data scientist. We say create value of right from the data. You'll get the data, but what is that you're doing with the data, right? So that's very important, which defines the value. But in order to ensure that these people are doing it, data has to be made available. Right? And data engineers develop these pipelines, ETL or ELT or combination of that, and use different tools, technology to ensure that data is made available. If you're dealing with very large businesses, there's a huge set of data points that are getting collected on a daily basis, and generally data warehouses or data lakes are used to dump the data, from where different teams can collect the respective data that they require. So that's a comparison. And see, with respect to job roles, the demand is both, I mean, in the I should say in all the areas where data is critically being playing the center role, the job roles are always there. These are some of the numbers that you can see from the different articles that we captured. This is pretty old. This was basically because of post-COVID effect. COVID-19 has transformed a lot of businesses. They made it mandatory for a lot of businesses to convert online. So as soon as the businesses become digitalized, a lot of data is getting generated, and they needed data engineers to ensure the data that they are generating is accumulated. That's where the rise of data engineers came to forefront. In 2022-23, there's a huge demand for data engineers, thanks to COVID-19 effect. You can see this article, which was published in one of the forums. I mean, this is one of the organization which deals with HR related operations. They say that the job interviews, right, with respect to data engineering specific roles have increased 40% in that year, 2022 and 2023. This is the the first fastest growth, and the second fastest was the data science. Yeah, so you can see the demand for data engineers has suddenly grown because of COVID-19, which pushed a lot of businesses into digitalization. People were already dealing with the business in a digital form, digital platforms. They already had teams, but suddenly a lot of people had to move, and because of that, suddenly a lot of rise in the specific roles and responsibilities are seen. But there are such interesting articles you can see, and these are the kind of numbers with respect to salaries that we have seen or observed. And this is also in the last year, you can imagine 2023, 2022-23. This is with respect to 2021 information, and this is consistently going on. Because we are talking about the skill sets. Python would be one of the important tools, because without Python, we cannot really do anything. And Python has the flexibility to interact with different softwares. It's an open source, general purpose programming language. So for data processing, we use this. Data scientists use it, data analysts use it, data engineers also use it. Then data generally lies in database softwares predominantly for majority of the companies, 99.9%, I should say. So in order to interact with those systems, SQL is required. So we also see SQL as one of the next important skill set that data engineers should possess. And then we have cloud, we have big data systems, right, etc. Things come into picture. The data engineer's salary can be seen as 8 lakhs base salary. This is somewhere around L2 position, right? And you can see with respect to this is with respect to Glassdoor, and this is with respect to the pay scale norms. These numbers are pretty much consistent, and they are going in upward direction. They don't come down; they go into upward direction. So, on an average, you can say people who have around, let's say, 1 to 2 years, or maybe 3 years at max, right? They come into this category, L2 category. All right. So this is the kind of salaries that we are looking at. And a senior data engineer who has probably 4 to 5 years or 4 to 8 years, they have 15 lakhs per annum salary packages. And more than that, you can see, right, 19 lakhs on an average is the salary. These are on an average numbers. You can always explore these platforms which basically do this survey. Even LinkedIn, for that matter, you can check even in the LinkedIn articles, and what are the current numbers you'll get to know. They are very much similar to this. So this is something that you need to understand, and why we need to give importance to data engineers is because organizations are trying to implement solutions which can help them grow in the right direction. And these are the important areas that businesses are looking to implement. But in order to implement this, you need data engineers, right? Very simple. Without data engineers, there is no data. Without no data, there is nothing that we can talk about. The organizations, right, they transform this way. In all the olden days, right, probably our parents' time or our grandparents' time, businesses were very reactive. Reports were generated after the transactions completed. Monthly reports, weekly reports, etc. And these reports, right, they analyze the reports, and they have been generated from probably pyramid times, construction of a pyramid times. This is always there. Okay, this is always there. But now businesses are trying to implement machine learning techniques to ensure whatever they understood here in the past, right, the pattern that they observed, they are trying to use these scientific techniques to map that to future. So we're saying that, yeah, this is how the business is growing. Fine, but what happens in future if the same pattern continues because of various factors which are influencing it? Then in future also I will be seeing this result, the pattern. So currently you are here, but in future you will be here. So that means there is some growth. So scientifically, we will be able to foresee the future, right? I mean, we upfront see the future. This is what businesses are trying to do. And thanks to this machine learning implementation, thanks to this mapping, the effect of these different factors on outcome is understood. Now, thanks to this information, we can control those features which are affecting the outcome to ensure the desired outcome is obtained. So we are creating that new feature rather than just waiting for things to happen. So here we are being proactive. This is what businesses are trying to achieve. And thanks to this, entire flow that we are discussing here is being automated. We are not manually doing anymore. We implement this flow in such a way that the system or the machines explore all these possibilities and understand what is the best possible outcome. And depending on that uh, um, objective of the best outcome, the remaining steps are automatically implemented. So we are automating basically in short, like driverless car, for example. What you do in a specific situation, as a human, what would you do or what you have been doing? We use that information, we understand what is the best outcome, and then we will train a computer saying that, hey, this is what you have to do in this situation. That is AI. So this is where the transformation is happening. Businesses are going to this level. But in order to ensure that this is automatically implemented, you need to have that data consistently flowing into the system. So everything again is responsibility of a data engineer here. Because unless until data is made available to continuously flow into the system, you cannot implement this. So we are at a stage where automations are basically happening, right? AI solutions are being developed. And for that, data has to be consistently moved. And as a standard, the data solutions are always implemented using this specific methodology. We call it as SMLQ. It contains 6 steps. This is nothing but a development life cycle, product development life cycle. Or specifically, we talk about a machine learning model. Life cycle or workflow, we call it as. This is the golden standard that industries use. So what we are trying to do is implementing an automation with respect to data pipelines, which basically allows the data to flow through this set of implementation steps. This is called as a machine learning pipeline. This is the role of a data scientist and machine learning engineers. Okay, they implement the solutions or they develop the solutions, and we ensure that we go in the same path as data scientists go or data analysts go, and ensure that we and make sure that data is basically being available for them. If you observe that that is the only statement I've been given right from the beginning, I'm only saying one thing, that is data needs to be made available for other teams so that they can actually leverage on it. And as data engineers, our responsibility is to ensure data is made available. So for businesses, they will have a lot of questions. And without data, they cannot do it. So this is basically a data engineer role, I should say, which allows the data to be accessible. The data is collected, data is basically cleaned, prepared, and then different manipulation steps happen. And data is then pushed to the data scientists or machine learning engineers. They consume this data to build a solution. So when live data is coming in, this is offline, right? We give one set of data, and then the data scientists implement the steps to ensure that something is developed. But that developed solution has to be implemented in the live world, right? Live scenario, production scenario. So that means live data is coming in. Now, live data is coming in will not be directly pushed into the solution, right? The model that these data scientists and machine learning engineers are developing. Because it's not magic. As soon as data is seen, it doesn't directly go here and solutions are obtained. No. It has to go through the same sequence of steps that are implemented. Like this. Only then you'll get the solutions. Right? So a pipeline does not mean somehow magically data goes to solution and comes output. No. Whatever the solutions that these people are developing in machine learning development lifecycle, the data has to be pushed into the same flow, even for new data that is coming. Sequence of steps will be there. All right. So this basically generated the ML pipelines. We call them as machine learning pipelines. The concept is very similar, what we discussed till now. But this is with respect to the specific model development. Objective is to get machine learning knowledge. Right? So the objective is to ensure data is flowing through different phases of the development. Right? For example, this is one architecture that majority of the businesses use. We call them as Lambda architecture. I'll take an example of Amazon. Amazon has historical data. So, for example, you are a customer and you have an Amazon account. When I say account, it's a unique ID that Amazon gives to each customer, login credentials, for instance. So, whatever transactions you have done till now is history, right? So, all that information is there in the master data. But at this very moment, the live, right? At this very second, you logged into Amazon and you're navigating to different products. You're browsing. So this is something which is happening by Amazon, right? They track this. We call this as web analytics, website analytics, or we can talk about that. So Amazon as a website has this specific feature which allows Amazon to track the users' behavior on their website. Many companies do that. This gives the current view, which is called as speed layer here. So real-time view. I'm as a customer, right? I said you are the customer. You probably went into a specific product page. And similarly, you are looking at competition products, different manufacturers of the same product, right? You're browsing through those pages. All this is information that Amazon is getting. So there is data coming from two different platforms. One is batch layer, which basically is coming from a stable data repository. And then you also have real-time platform where the data is getting collected or captured from the website itself. Now, when you need to take a business decision, we try to look at the information from both these platforms and give results to the end user. End user could be consumer of this data, right? It was not customer. End user could be the management. So here we are talking about data end user, who's nothing but the management, who would take this information from both the platforms to build some strategy or offer for it, right? And this is one of the architectures that we've been talking about, friends. Lambda architecture. It's one of the different architecture designs that we have in the industry as a practically implementation of the right various integrated tools. I mean, organization as IT infrastructure, right? So how the data is flowing in these different systems that they are maintaining is nothing but an architecture, data flow. So Lambda is one such architecture which is implemented by majority of the companies. Why is it called as Lambda? Because of this two different sources. We will have batch layer, we have speed layer, and that gives you the result. This is, let's say, batch layer, and this is called a speed layer. And what we get is serving layer. Serving is nothing but the end user results. Or you can say, I mean, whatever the design, right? You basically see that Lambda shape. Hence the name Lambda. So we will be trying to learn these kind of architectures as part of the pipelines. And these are the strategies that we will have to implement. Whatever the tool or technique or technology that we are using to build a pipeline, we have to ensure that the pipelines are built using certain tools which are easy to implement, at the same time easy to maintain. This is basically a contradictory statement. These always complement each other. They negate each other, I should say. If you're using a software or tool which is easy to implement, then that means it is automated. And if you're talking about an automated system, then you'll not be able to do a lot of maintenance on it. You cannot do customizations. So we need to balance between these two. If there is some customization required or some issues arise, then you'll not be able to play around with a lot of things because you have a readily available solution, right? Automated solution. So you not know what is happening in the background, right? So this is the trade-off that we have. But we need to try and analyze the requirement of the business and then try to balance between these two. It's not just the implementation, but after post implementation also, the use of that system should be simple and easy to maintain. The tool should also be flexible, right? It should allow to deal with data which is generating in different sources in different formats. And data security and data privacy standards should be supported by the tool. Right? The data that we are consuming from the tool should be reliable. So data security and data privacy have to be implemented, and data loss should not happen. And finally, when we talk about all these steps, right? Predominantly, industry was always dealing with offline data, batch mode data. So a lot of tools are available to do that. But the tool should be flexible to do real-time data streaming as well. This is the need of the hour, right? So as the data is generated, we need to move the data in real time, right? So these are some of the standards that we will have to look at when we are trying to construct a data pipeline. And these are some of the tools. I'm not saying this is or this will be the only list, but there are additional things that we will be learning. So to start with, right, as a journey, we will be trying to look at the sources of data, then the data transformations, right? And this is also a source for real time. This is also a source for very big data. large data that we have, right? So these are all the tools for sources. For transformations, for integrations, we use Python. This is the superstar. But if I have to deal with processing very large amount of data on a distributed environment, then we will use Spark also. But here also we will be using Python. So we will have something called as PySpark that we will be using. And after that, we need to ensure that this integration between source and destinations is happening using either Python or ETL tools. Right? We will have different types of ETL tools. In fact, thanks to cloud platforms, we have something called as visual ETL tools. We will be learning about them. Like AWS has Glue. ADF is very popular. Microsoft Azure Data Factory, which is a visual ETL tool. We'll be learning these. In GCP also we have Data Fusion. And then we have the data warehousing solutions. This is the destination. BigQuery is popular from that perspective, and AWS has Redshift. Here, Azure has something called as Science. So there are different tools that we will be learning. Each of that has its own purpose, as I'm trying to explain here. And we will start from Python, because without Python, a lot of things are not possible. You will be learning right from the fundamentals of Python programming, the data standards, which basically explain how do you do data preparation and data transformations, data cleaning. And then we'll also learn about SQL and NoSQL. Detailed SQL discussion happens. And NoSQL is very similar to this, but special capability. So we will discuss about that special capability as well. Then we will talk about big data systems. We'll talk about cloud platforms. We'll be talking about real-time streaming, and you'll also be doing projects with respect to real-time streaming on cloud platforms. So this is basically what is covered, right, from end to end as part of the program. I'll quickly show you the content as well on the website. If I have, this is the website, this is the page. If you look at, this is the content. We're going right from Python basics, right? All the fundamentals of Python. Then we will be talking about the project management steps, the crisp MLQ, and basically the various fine tuning of the data and preparation of the data, where we do trimming, outlier analysis, right? All these things, listing value handling. So all these are different steps that we implement. Then comes to the SQL programming, right? And then how do we use the source destinations concepts for building the data patterns? So once the data engineering basics are covered, we will be talking about NoSQL here. SQL is already covered. And then we will have the big data platforms. The concept of big data actually made way for the cloud systems also, right? So we'll be understanding what is the concept of this big data distributed framework scenario altogether. Then we will also talk about the processing tool, which is Spark. As I told, right, we will be implementing PySpark to do the data analysis, data extraction and data cleaning. Then we have messaging system Kafka, which allows us to capture the real-time data. Then we will talk about Airflow, which allows us to automate things, schedule things, and right, it's called as workflow management tool. We will also be using this Apache Airflow to building the pipelines and triggering them. And then we move to cloud platforms. Introduction to all the three cloud platforms will happen. And post that, we'll be talking about the ETL tools and the data lakes and data warehouses on that respective cloud platform. We'll be talking about all the three clouds. So with AWS, what are we supposed to do? So there are tools like Kinesis, Lambda, Glue, Redshift. For analytics purpose, we do QuickSight. Then on Azure, the same flow. The tools names are different, but we'll be talking about these tool implementations. Then in GCP also we have the same flow. And we're talking about these different softwares. And finally, you'll be also looking into the real-time project as well. How do you capture the data live from various IoT sources, move that to the cloud-based data sources, and from there, how do you create value for that particular data? So this is one use case that we will be implementing as part of the entire course content. And you'll also be given this Sunny University modules, and you will be able to get a certificate from Sunny University, which is one of the largest universities in New York. Right? These are the modules that you'll be getting. Microsoft Azure and Google Data Engineering. Right? And as I told, you'll get that certificate from Sunny University. Of course, you'll have to write an exam based on the videos that will be shared from Sunny University. So this is one certificate that you'll be getting. Another certificate is from 360DigiTMG. And the most important thing is after all this course is completed, you would be given an opportunity to work with us as part of the projects that we work, right? Remember I told I'm basically one of the directors of Innodatatics where we deal with a lot of client projects. So you will be given an opportunity as an intern to work on those projects. You'll be working with the teams of, along with the teams of machine learning and data scientists and data analysts to help them build these pipelines. That way, we cover your practical exposure as well. And for that project, you'll also get a certificate for that right internship duration that you have worked. So this is the overview of the entire program. And yeah, if you have any questions, please let me know. I would like to conclude here with respect to the Introduction to Data Engineering course from 360DigiTMG. Any questions you have? If you do not have any questions, then you can conclude the session. And I request you people to connect with our team whenever you have any question. Do not hesitate. We are more than happy to address your queries, help you take the right decision in your career.
So I was wondering how many students will be there in each class?
That depends. We cannot have a fixed number because it's a open session. We may have maybe I should say I have covered data engineering previously. I have seen 3 students, 2 students to 10 students also. It varies. Okay, but for Python, for SQL, you may see more number of people. But once those concepts are completed, when we come to the actual big data platforms, the cloud platforms, then the number comes down because you are specifically focusing on the specialization of data engineering knowledge. That's when you will see very few people.
And well, I do not have any IT background or, so how, I don't know if this is really going to be my cup of tea since I don't have a baseline. So if you can help me understand, I'm interested in getting into IT, but I'm lost on what career path I should be choosing. So
yeah, so the similar question was already asked, and we did cover with respect to certain things. I mean, I explained certain things here. It purely depends on your interest, right? Your education background and work experience will play a role, but it is not the primary role. It all depends on what you want to do. To help people who are coming from this non-IT background, non-programming background, we cover things right from the basics. You can see the fundamentals of programming are covered here, right? So you'll have the platform to learn right from scratch. But are you really having that mindset? Do you really possess that zeal to get into this IT world, get into this programming world is something that you will have to take a call on. You can also choose, right, a data analyst role for that, or data scientist role for that. Yeah, but as part of the data engineering program, we cover all basically the backgrounds. We think about experienced people, we think about freshers, we think about people who are coming from non-IT background. So all those aspects are covered as part of the program that we are offering.
Okay, thank you.
Welcome. You might want to have a one-to-one discussion with the counselor, career counselor, and depending on the discussion, they will be able to suggest you an appropriate program. Right? I don't recommend blindly jump into this data engineering program. You'll have to analyze, you'll have to assess your situation, you'll have to assess the program content and then take it. So help yourself, right, by assessing the conditions. And for that, career counselors would be an appropriate point of contact to help you choose the appropriate program. They will be able to guide you.
Okay, sure. Thank you.
Right. Okay, all right. So if you have any further questions, friends, please do not hesitate. I've given my LinkedIn profile as well. This is my LinkedIn. You can always connect with me here. I'm not that active, but I'm active. So you can always ask your queries here directly, one-to-one over LinkedIn with me. I'll be happy to address your queries. Right, and yeah, that's all from my side. I'll wrap it up now. Thank you so much, and looking forward to interact more with you people. Have a pleasant day. Thank you.
Thank you.